All right, guys, back again. And I'm not sure if you're going to be seeing this with me here or not. I'm going to be out of town for a conference, and I haven't decided yet if this is what you're going to do while I'm gone or before I go. So this video is going to go a little bit slower, just in case this is your only introduction to the topic. But what's kind of cool about this topic is last time we introduced you to functions. F of x to absolute value functions. F of x was the absolute value of x. And you learned that depending on what I did to this, we called this the parent function. And depending on what I do to this function, it changes the graph. If I add something, if I do absolute value of x plus 7, whoops, that's supposed to be a plus, that's going to shift me up 7, right? And if I did absolute value of x minus 7, that was going to shift me to the right 7 places. Well, today we're going to use those same characteristics and apply those to a different function. And that's what's kind of cool about these functions is if you can remember how it affects one function, that's actually the way it affects most other functions. So today we're going to talk about radical functions, or in other words, square root functions. So our parent function, y equals the absolute value of x. That's or f of x, because we're talking about functions, right? F of x equals the absolute value of x. That is our parent function. And then if I do things to it, it's going to change my graph. All right. Now my parent function, just to give you an idea what it looks like, let's go to our y equals, and we're going to do second square root x, just to show you what this graph looks like. So one thing to notice is we start at 0, and it goes up pretty dramatically at first, and then it slowly starts to level off. Now, it's never going to level off completely flat, but the further to the right we go, the flatter it's going to get. But if you notice, there is nothing to the left over here. There is nothing on this side of the graph. It goes from 0 to the right. And you're going to see why that happens here in just a minute. So if we have our original function, and you may want to draw that here on your graph, if we make this our original function right here. So basically, your first point is actually going to be at 1, 1, and then it's going to slowly start to level off as you go to the right. Now, we can adjust that by doing things to the original function. So here's kind of a breakdown of how that works. And again, what's cool about this is it's the exact same as the absolute value functions. If I put a negative in front of the square root, that's going to flip it over. So if I go to my y equals and I change this, if I insert a negative sign, all that does is flip my graph upside down. Okay? And that's what it tells you right here. Reflect in the x-axis. If you want to write flip over, right there you can. So the negative is going to make it flip over. If there is an a being multiplied in front, now be careful, not a little number up in the square root. If there is a big A in front, it's either going to stretch it or shrink it, just like the absolute value. So on my graph here, we're going to go back. We're going to change this to a normal one. And what I'm going to do, I'm going to make this red graph. Oops, we don't want to do that yet. Let's, out in front, let's put a 5. And then I'm going to put the square root of x. And that's going to be my red graph. My black graph, I'm going to put a fraction. I'm going to put 1/4 in front. And then I'm going to put square root of x. Now, when I graph these, there's my original graph. And look at what the big number does. If I put a big number, it makes it taller. It stretches it up. And if I put that little fraction, it makes it short and squatty and fatter. Okay? So just like the absolute value function, a number in front is going to stretch it, or it's going to compress it or stretch it. depending on how big that number is. So a regular number is going to stretch it vertically, and a fraction is going to compress it, or in other words, make it look short and wide. And then the translations. These are the easy ones. If there's a number inside the square root, if I have something happening in the inside, that's going to be my right and my left shift. But remember, it's going to go in the opposite direction. If it's a negative number, it's going to shift me to the right. If it's a positive number, it's going to shift me to the left. So just so you can see what that looks like, let's go back to our y equals here. I'm going to get rid of these ones. So if I put underneath the square root, if I change this to a +3, it's going to be the same graph, but that +3, instead of starting right here, is going to shift me over to the left. And if I were to make that a -3, it's going to shift it to the right. Okay. Now the number on the outside, if there's a number on the outside, that is my up and my down shift. Okay. So if I put a plus on the outside, if I put a +3 over here, that's going to shift me up 3. And I also got shifted to the right because I left that -3 underneath. So it's the same graph, it's just shifted based on what numbers are being added or subtracted in the function. So again, the nice thing about this is it matches the absolute value. If it's on the inside, it shifts left and right the opposite. On the outside, up or down in the same direction. So what I'd like you to do is pause the video, and I want you to try numbers 1 and 2 on the homework. This is homework number 12. And I just want you to try numbers 1 and 2. I want you to see how you do on those ones, and then start the video and we'll move on to the next concept. All right, guys, moving on here. We're just going to try this a little bit. We're going to take our picture and we're going to shift it. So on all of these, I'm going to use this middle. Wow, that's, I can't even live with that. I'm going to make myself redo that one. I mean, I can live with some crookedness, but that was out of control. Okay, so the absolute value of, the square root of x -4. The -4 is on the outside, which means that's going to shift me down 4. So instead of starting at 0, I'm going to shift 1, 2, 3, 4 down to here. And then square root graphs are a little bit hard because finding the exact points can be a little bit difficult. All I care about is your first point and probably your second one, because it's usually over 1, up 1. And from there, as long as you are reasonably going to the right and up, we'll count that as the right graph, okay? Now the +5 on this one, absolute value of x +5, means now it's on the outside. So that means that my shift is going to be up 5. So instead of starting at 0, I go 1, 2, 3, 4, 5, which means I'm going to start here and I'm going to shift to the right. Or not shift to the right, I'm going to go up and to the right with my graph. Okay, the +6 on the inside, remember that means I actually go to the left 6 places. So we're going to shift our graph this way just a little bit so that we can actually fit our picture in here. So instead of starting at 0, 0, I have to shift 1, 2, 3, 4, 5, 6 to the left. And other than that, it's the same picture. It's just shifted to the left. Now the -4 on this one is on the inside, which means I shift to the right 4 places. So if this is my origin right here, wow, we're going to let that one go. If I shift 1, 2, 3, 4 to the right and then draw my graph, see, at least the graph looks reasonable, even if the line doesn't look reasonable. And so that's it. Just like the absolute value, those numbers tell you how the graph is going to shift. And you don't have to plug in a bunch of numbers for x to see what you get for y. Okay, so pause the video. I want you to try numbers 3 and 4. Remember, this is homework 12. Try 3 and 4 and see how you do. If you have any problems, come and see me. All right, moving on. Multiple things at once. So those graphs weren't too bad because only one thing was happening. In this case, what's the graph of y equals 3 multiplied by the root of x plus 2 minus 4? Well, this plus 2 shifts me to the left 2. This minus 4 shifts me down 4. And this 3 stretches me 3 up. So I'm going to go left and down. So I'm going to make my center over here just a little bit. And instead of starting at 0, I'm going to shift to the left 2 and down 1, 2, 3, 4. And then here's where this stretch comes into place. Normally, I go up 1 over 1, but I'm stretched by 3. So I actually go up 1, 2, 3 when I go over 1. So my graph is going to be a lot taller than it normally is. It's going to take a little bit longer before it levels out. Okay? And then on this one, the plus 2 is going to shift me to the left 2 places. The minus 1 on the outside is going to shift me down 1. And the 1/2 is going to shrink me. It's going to shrink my graph because I don't go up and over. I don't go up as far when I go over. So we got to go left and down. So let's draw our coordinate grid here. Now I'm going to go left 1, 2, and I'm going to go down 1. So that's my starting point. Now in this case, remember the fraction. This is my up and this is my across. So this means I go up 1, but I go over 2. So this one's actually going to level out a lot faster than the one that got stretched. Okay. All right, pause the video. Try number 5 on the homework. When you're finished, go ahead and hit play and we'll move on. Okay, last thing for the day. And this one is a little bit more tricky than the absolute value functions. We're talking about the domain and range, or in other words, remember the inputs and the outputs of our function. So to find the domain of a square root function, what you need to remember is that the outcome needs to be a real number. Or in other words, the discriminant, or in other words, this part that's under the square root has to be positive. Okay, I know when we were talking about imaginary numbers, we were able to still find solutions with imaginary numbers. But when we're talking about a graph, we cannot have negative square roots. That doesn't work. And how this comes to play with our domain and range is for this example right here. Y equals the absolute value of x plus 3. Or sorry, the square root of x plus 3. I have absolute values stuck in my head. So what happens when I start plugging in x's? If I plug in 1, I get the square root of 4. If I plug in 2, I get the square root of 5. If I plug in 0, I get the square root of 3. If I plug in -1, if I plug in -1, I end up, so -1 plus 3, that's the square root of 2. And watch what happens. If I plug in -2, -2 plus 3, that becomes the square root of 1. If I plug in -3, -3 plus 3 becomes the square root of 0. That's okay. The square root of 0 is just 0. But look at what happens if I go any lower than 3. If I go to -4, I end up with -4 plus 3, which is the square root of -1. That is bad. We cannot have a square root with a negative underneath it when we're talking about domain. So what we have to do is, in this case, my domain is everything that I can plug into X that does not make this negative underneath. And if you noticed from my example, that meant that X cannot go any lower than -3, but it can go up as big as I want. It can go up to infinity. Okay, it stops at -3 and it goes up to infinity. Now look at what this looks like on the graph. If I go to y equals and I go second square root of x plus 3, and then we look at what the graph looks like. Notice that right here, my graph stops. There's nothing to the left over here. It does not go to the left forever. It goes to the right forever, but it stops right here at -3. So one of the ways to find the domain is to look at the graph. The other way is to figure out what's the smallest number before this starts becoming a negative. Okay. In this case, x minus 6, we could look at the graph, or we know it's going to go up to infinity. It's going to go to infinity forever. But what's the smallest number that I can use? If I plug in a 6, then I get the square root of 0. But if I plug in a 5, I get the square root of -1, and that's bad. So 6 is the smallest that I'm going to be able to go for my domain. Okay, and if I look at the picture, if I go to y equals and I change this to x minus 6, whoops, let's get rid of that plus sign. X minus 6, notice that my graph does not go over here at all. It stops at 6. So that's why my domain is from 6 up to infinity. Now, if it wants you to write your answer as an inequality, then that would mean that x can go up above 6 forever. And this one would be that x can go up and above -3 forever. So you can use interval notation or as an inequality. These are the same thing, depending on how the question wants you to answer it. Okay. Which is something you're going to have to pay attention to, because I believe the homework is going to ask you both ways. Now, the range is all of the possible outputs, and that you just find by, I think the easiest way is just looking at the graph. So if I look at my graph, remember my range is my up and down, my y's. And looking at this, it's going to go up forever, but it never goes down below 0. So my range for both of these, my y is going to be greater than or equal to 0. That's going to be my range, all of the possible y values. Now that's going to change. Obviously, shifting it left and right, like these two did, is not going to change my range, but it is going to change my domain. Now, if I were to shift up or down, if I said the absolute value of x plus 6, then my domain isn't going to be affected. It's going to just start at 0. But because I'm shifting up, that's going to change my range of my function. So if I put that plus or minus on the outside, delete that for me. So if I put plus 6 on the outside, then my graph is shifted up to 6. So that means my range is now from 6 up to infinity. So it would either be from 6 to infinity, or y is greater than or equal to 6. All right. So what I want you to do, pause the video, try number 6 and 7. This changes a little bit. This domain has always been all real numbers up to this point, but it's not anymore. Now there's actual values of x that don't work, and we can't include those in the domain. So try 6 and 7. When you're done, go ahead and finish homework number 12. The problems look exactly like what you've already done, so there shouldn't be any surprises there. If you get stuck or you need any help, come and see me.